Hey everybody, this is Larry. This is day 4. Oop, I see that, the page has crashed on the on the thing. I have to refresh. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Yeah. Okay, I don't know. Hope everyone's doing alright. Today I am okay. I've been doing the advent of code. Hope everyone's doing it. Or I don't know. I mean, you don't have to do it on the day off, though. I am trying to get the leaderboard, so I am trying to do it. But yesterday was a beating. I did not was not as comfortable with a regular expression as I would like to be. Actually, I'm pretty comfortable with a regular expression, but it's just very hard to kind of, you make a typo and then it's just hard to debug. And also, I'm just not familiar with Python regex because it doesn't really come up that much in competitive or real life, really, right? Because I mean, I guess if you're parsing things, it could be useful, but I think in those cases, you probably don't want to use regex anyway. I mean, it's good for like a quick and dirty scripting thing, so maybe that kind of Python, but for production level code, I would say it's very rare that I mean, it depends on how close to a service you're doing, but I just don't know if there's a really legitimate case where that could be true, except for maybe scalping, because you really don't want to do like user validation things with regex or and these kind of things you really don't want to do at all, really. Just find a library that does it for you is probably the way to do it in production. So anyway, that's a long way of saying that I sucked at regex. Just don't know the syntax well enough with respect to how it incorporates a Python, and I also misread a part. Not misread, but I just thought it'd be one line for some reason, and I just kind of made a silly mistake. All these kind of add together, and hopefully today I'll redeem myself a little bit. Still haven't been on the scoreboard yet, so that's kind of a little bit of a sad couple of days. But anyway, still it is fun. It is kind of exciting. It's like getting a GIF every day, so we'll see. Anyway, let's get started. Today's poem. Today we have 2825 mixed string a subsequent using cyclic increments. You're given two zero-index strings, string 1, string 2, string 1, string 2. In an operation, you select a set of indexes in string 1, and for each index I in the set, increment to the next character. Okay. A becomes, okay. Return true if it's possible, make a subsequence of at most once. False otherwise. Okay. So you do this operation once, and then that's it. Okay, let's see. And you want string 2 into a subsequence of string 1. Do we modify string 2 or modify string 1? It's not super clear. Okay, so you actually modify string 2. Okay, and then see if string 2, you modify string 1 and then see if string 2 is in it. Okay. What does this mean, right? So I think the first thing to do with these poems is just really understand what they're asking for. And what they're asking for is that, put it another way, string 2, all the characters have to be in string 1, right? So what that means is that you have A and D. I'm trying to, I did take a peek at the length, and it does seem like, there's 10 to the 5th, which means that n squared or something like that cannot be done. This leaves me with two ideas, right? One is greedy, the other is dynamic programming. Dynamic programming is not super difficult to conceptualize if you have enough practice, because the key note is that you can only make this change once. And what that means is that, well, for every index, you either made the change or you didn't make the change. And then you could draw you could take the time to write the transitional states for that dynamic programming. But that's how I think about it. Is there a greedy solution, I wonder? So, okay, so for example, let's say we have A, B, C, A, B, C, D, E, and then we have A, D. Well, in this case, you can change the C, but you can also just take the D. That's tough to say. That's the hard part about greedy, right? Is that you have to prove yourself correct, and even before that, let's say that there are multiple ways to be greedy, right? So, and then it's like, well, you know, I think I don't know that there's a greedy, or at least I don't know that the way that I would do it, like a left to right greedy, would probably not make sense, just because there are so many decisions that you can make, right? Like, for example, maybe you can have A, B, C, 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 D, E or something, and you have like A, D, right? And then A, D, E maybe. Then which one do you choose, right? I mean, I know that this is like you can maybe go with a rule or whatever, right? But you know, but that's the thing with these rules, is that like you could make up something like, oh, I always choose the one to the right most or something, right? But in that case, you still have to prove that, and I don't know how there is, and it means that you leave the possibility of a counter case, which is the same as being wrong, right? But yeah, I don't know. Wait, did I misread this one? Oh wait, I misread this one. Sorry, friends. Well, it's a good thing I'm misreading it now versus the advent of code, I suppose. You're supposed to select a set of index, not just one index, and then you could do it. So that means that okay. So this is much easier, much sillier. Okay. Yeah, so basically now what it is saying is that for each character, oh sorry, you can select all the characters, right? They want you to, so what this thing is that they want you to select all the characters at the same time, which is kind of tricky. But the thing is that your selection of this set, every index is independent, right? Meaning that if you choose an action for index I, it never affects any other I. So as a result, you could decompose your one operation of a set of indexes into just per index operation, right? So that's really the idea about it. Yeah. Yeah, I mean, I think that, and this is, yeah, you just kind of go from left to right, and then you could only use it for each index once, so that's the actual limitation, right? Wow, how did I misread this one? And you can think about it in any number of ways. But yeah, as a result, then in this case, you can do greedy because using that cost, using this thing, you can always use it, right? And it doesn't cost any more. So the greedy is actually on the fact that you're minimizing the prefix that matches the prefix of string 2, and as a result, that gives you in a greedy way more characters to match with string 2, which you can do actually like a easy exchange argument to prove that it is optimal, right? The exchange argument is basically like, okay, given the same string of length 5 or length 6 to match with string 2, well, you always take the one that's longer because you just have at worst it'll be equivalent. At best, you take another character off, right? So something like this. I mean, I'm a little bit hand wavy, but yeah, okay. So then maybe we'll just do yeah. So for j in range of m, right? If string 1 of I is equal to string 2 of j, or whoops, what I want is while string 1 of I is less than n, and string of j is not equal to string 2 of j, then we increment, right? I didn't do the other thing of flipping 1, which we can add for a second. I mean, so this is just like a regular subsequence thing. Just want to get that right first. So if I is equal to or greater than equal to n, then that means that we return false because we ran out of characters. Otherwise, we just return true. And then, yeah. Otherwise, we increment 1 because this invariant is that in here, string y sub I is equal to string j sub j. So that's basically it. We didn't do the +1 thing yet, but I just want to make sure that I didn't get the index wrong. I mean, that's fine. I was looking for, if I like get out of bounds error is what I was looking for. So it's either this, and something like this, right? So something like that, but obviously not that because you can't do this for character in Python. So maybe something like, I don't know, just write a function for, I just call it f because I'm lazy. Maybe f to get the next one, right? So f of character c, we have minus this will give you the index. We add 1, we multiply by 26, and then we add it back this thing, and then we convert it to a character, and that's it. Yeah, okay. Was just double checking. 1709 day streak. But yeah, this is just linear time, linear space, right? Actually, is it even linear space? No, it's not. I was still thinking about the DP one, honestly. So even the DP one, like what I was saying, you can actually do that in O1 space too. So I don't know. Anyway, yeah, pretty straightforward if you read this correctly. That's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.